second, depending on the modulation and code rate and so on. So the SNet mission is basically accommodating this main payload, the S-Link payload, and will be put into orbit. Here are the key parameters of the payload. So I don't want to go by line. Just you again see the variation of the data rates depending on the modulation. We have the BPSK, ADPSK, BPSK, and so on, and also proprietary coding. And we'll have a RF output of 0.5 watts. So the payload itself, the communication terminal, will be responsible for the first and second communication layer, and from the third, so the networking layer, the spacecraft controller will take over and do all those routing and networking protocol. Just a summary of the link budget for the crosslink. Let's just have a look here at the very last 3 lines. We'll have, for different code rates and different modulation methods, so you see the values of the link margin at a TX power of 28 dBm. And in orbit, we will be able to test different network topologies, which will depend on the orbit configuration, on the available resources, computation power, whatever, of the nodes, and also the desired quality of service and the network operating mode. So we'll test and verify different access methods, such as competition protocols, allocation protocols, as centralized, decentralized, and TDMA, and for different topologies, well, we want to optimize the different protocol parameters. Just a few words on the satellite bus. The satellite bus is a generic bus developed by our institute. You see the key parameters here, and all those will be launched from a container. So since the S-band does not really need strict pointing requirements, the attitude pointing, the pointing accuracy is, for this case, relatively coarse with some 10 degrees, but it is sufficient. We have our own ground stations at the Technical University in different locations, such as Berlin or Norway and Spitsbergen. And we'll do all the operating and yes, by ourselves. Just a few words in terms of frequency coordination. At the first, all the coordination is done by the DLR Space Administration, and we are of course very pleased to have Mr. Buscher in our department, who is also handling and dealing with as a interface between the administration side and our institution. And at the beginning, we saw, we applied for the inter-satellite service, the ES class, but in iteration we got the feedback that for our desired frequency there is no ES allocated, so we have to switch to the ET class, which is the Space Operations Service. Well, for UHF, which is handling as our nominal TTNC channel, we used the regular amateur radio frequency. And currently, we are in the midst of phase D, and since the notification was done at the beginning of this year or at the end of last year, we expect the notification, or the API was done a couple of months ago, so we expect, I've learned yesterday that I can expect the notification at fall, so way before we will launch our satellites. So at the beginning we had some issues about how to determine the orbital parameters, but we figured out by the process it is more relaxing requirement, so that was very helpful for us. Just a small, short word on the finances, since all the system weighs about 64 kilogram, including the launch container. If you are aware of the market price of the launchers, you might just very easily estimate the entire budget of the project. And the final summary. So the ESA mission will be the first mission which will demonstrate multi-point to multi-point crosslink with higher data rates above 100 kilobit per second, higher ranges or distances of over several hundred kilometers. And of course, one challenge is, since we do not have propulsion, the challenge is to keep those satellites pretty close to each other for a certain time, for the time of experiments. So we had some long iteration with the launch providers, which could ensure us this kind of upper stage stability to launch those satellites. All right, thank you very much.
Thank you, Zizung, and I'm happy to see it's a nice challenge also for us. We got the API filing, and we hope we will learn about your project more. And this is really one of the new directions of the small satellite networking, data collection, etc. We see that this will come as one of the next steps. Thank you very much. The next speaker will be Frank ZEPPENFELDT from ESA, and just reading quickly that you have a very nice position in ESA. This I would like to be the future programs. What can be a dream for a satellite engineer to be in ESA, a future program? That's why you have no limits. I'm sure that probably only budgetary limits, but no technical limits. Before you worked in NATO, that's why you learned how to follow all the rules, and now in NASA you try, ESA, to try, and before you worked in EUMETSAT, etc. Very nice career, and I hope you will show to us the development of some exciting projects in ESA.
Thank you. I thought we put it in Tuesday evening. Tuesday. Your colleague. Yeah. Yeah. Good. Thank you very much for introduction. We'll do this quick and to the point, I hope. For it's a bit, let's say, European-oriented presentation, because we are a funding organization, so we would also like to attract people who give to us and come to us with proposals and requests for funding. So we are in the area of satellite telecommunications, so commercial satellite telecommunications, Inmarsat, O3b, this kind of things. And we see more and more interest also from players to use smaller satellites for telecommunication services. Often this is in the area of machine-to-machine, ORBCOM type, global sensor network, these kind of areas. And we, as our group, Satellite Communications, would like to see more use of smaller satellites to develop sometimes niche services. And that is also where this presentation is about. And so basically we fund, sometimes we fund things completely because we write a tender to industry, we wait for bids, so we competitively tender this. But it should also not be forgotten, and I think that's very interesting for, let's say, European players. We often receive unsolicited proposals from industry, and we top this up with 50% funding, and such we develop equipment which is completely according to your specs, and it's also done the way you want it, including the quality assurance and the product assurance standards that you impose. So we are not imposing things like ECSS or other QA standards. Good. Further of interest maybe is that we also fund in-orbit validation demonstrations. So we sometimes have proposals coming in, say we would like to validate this sort of technology in orbit. It has to do with communication, of course. That is where we use the money for. Basically, we're sitting on a pot of money from various countries. You see there all the flags, and we divide that up according to certain rules. Good. This is the typical results of what the work proposals that we have received. Some of the things are flying. They are either on the ground segment, let's say here textile antennas, here Ka band horns, larger tanks, just examples. And of course, quite a lot of more feasibility studies, market studies also in the area of satellite telecommunication. What we think, what is missing to enable this addressing of maybe niche telecommunication services by smaller satellites is the things that we mentioned here. We see the first Ka band equipment coming up for small satellites for ES services, so 26 GHz downlinks. We see no equipment for actually FSS, 2030 for non-GSO usage. We don't see any equipment at the moment for those smaller platforms. What we also lack, I think, is increased gain of antennas, still maybe staying within the CubeSat or UTIAS type of platform, or maybe doing deployable structures. We see that missing, and I'm talking a bit from a European perspective. We follow closely the various NASA and other demonstration missions where you have deployable things, and I think we would like to see that also happening in Europe. We also lack, I think, low-cost inter-satellite links for maybe a bit higher speed data rates that were presented before. We'll come to that later. Another problem that is not technical, that has been discussed extensively. We'll come back to that later. And the other position that we have, that a number of things that you need for telecommunication, accurate pointing, things like that, some of those are already taken care of. They're being developed by the community doing X-ray instruments or other, let's say, non-telecommunication applications by smaller satellites. Where do we see now the gaps, let's say, in the different topologies? When we talk to people or companies that come to us with niche communication services, we see a number of topologies that are always coming back when they want to do a new machine-to-machine service, the super OrbCom or a new global star based on smaller satellites. That is this one where you have, I'll just give an example, something like this, like ADSB, this flight following, where you have all the host payloads on Iridium. People would like to do that, and then they want to have to use, data is generated on board, and they want to have that downlink somewhere very quickly. There is a latency requirement. Let's say 3 seconds later, the data is useless. So it needs to be downlinked quickly. Another topology is more high-speed trunking from point A on Earth to point B on Earth. That could be Arctic communications or other applications that need low latency. Now, we meet sometimes people that are exploring those ideas, and what is missing is lots of payload equipment in those bands, which would fit on smaller satellites. The other topology is, you could say, a rather standard one. Let's call it again machine-to-machine communication, a new OrbCom or a global star, talking to a LEO, but then having also decent feeder links for the small LEO. There we propose to do more work on C-band. And then there is a data relay possibility and current opportunity, we'll talk more about that, is to have small satellites talking directly to GEO and then feeding back it to a ground station. Now, in order to maybe close those gaps, which we heard and we generalized a bit when talking to commercial parties, we decided to initiate a number of developments. So we will issue now tenders to European and Canadian industry where they can bid. And that is a small Ka band FSS transponder, a C-band transponder that is a bit linked to one of the agenda items also in WARC 15. There will be, let's say, it's the global star feeder link for MSS. It would be good to have some equipment on that which fits on small satellites. We would like to issue a development for LEO to LEO intersatellite links. This could be maybe just intraplane, so no need for pointing the